Wait. So let's talk about how you can build complete dapps with AI agents. And these are not just generic dapps like some front end with some generic contracts, not at all. These are complete end-to-end dapps where you have contracts, front end, wallets, test, bunch of tests, and also deployment to dev node, testnet, mainnet, depending on your preference. So you can build whatever you want and however you want with Vara Skills. And what are skills, how we can use it, and these are pretty simple. This is very simple. So we will see everything in this video. Basically we will talk about Vara Skills, which is a public library for AI ready skills, from idea to fully deployed apps, smart contracts, front-end, wallets, integrations, advanced UX patterns, everything at once. And okay, what are skills for AI? Like AI agents works well, like they give you answers, they give you a bunch of things, but skills basically are your local skill.md files, and that instruct bundles that tell your AI agent specifically to how to handle specific workflows that you have customized. And also you have like personal preference, whatever you want to build, and then like there are specific workflows correctly, instead of just guessing, okay, maybe this is the thing that a person wants or something, but now it has custom instructions and bunch of other things, API configurations, and no like proper wiring between the contracts, the client side, and also the front end. So there's no planning artifacts. But with Vara Skills you can have doc-based sales workflows, correct ideal file, there is client generation, just one line, it already does that, so you don't need to take care of that. And there's gtest smoke deploy, means you can have your local dev node that can run bunch of things, and you don't need to write tests, it automatically tests it out for you. Then you have real, like the basically all the things that you need, from specifications, architecture, tasks, and code, it does this for you. You describe the task, your pack route itself, and there's like build and validate. First of all, the Vara network on the chain, you will build this sales, the framework that you will use, not you, your agent will use specifically, and also the skills that it will use to build all of this. Then how you can actually do this, you have two ways with Cloud Code and Codex. You can just go to this website as well, like vara.network/agentic-development, then like this one here, and you can just add skills to your agent from like Cloud Code. You can add it to this way. We will use Codex here because everyone knows how to do in Cloud, but we will just try to do it in Codex. So basically you can just install these skills on your agent. You can just verify with /skills that it already has it or not. Then you can just write it a demo prompt like build an on-chain property procedures game, but we will try to have a tic-tac-toe game, or you can do actually anything. I'm just giving you examples. And then cursor, copilot, OpenClaw, bunch of things are coming, there's already in the pipeline. And also whatever you want to do, you can just go in what we are building here, the foundations that are available, there's developer tooling, there's ecosystem infrastructure, there is almost applications on the way for you guys. So then you go to agent workflow, there is planning, there is build, there is verification, then there is ship. But all of this happens one by one once it completes the first task, and then it completes the next task. So you don't need to take care more about how it works and all those things, but you can check it out, verify every time. Then what you get, you have your app structure, you have smart contracts, you have React front end, you have tests and validation. Also we will just try to build something like this that we have, you can see right now. Then what else, you can just fork it, prompt it, ship it, easiest way possible. Codex, you can just go here. I will be using the like CLI one, so you can go for CLI. You can install, like we have already everything set up, so let's see how it works. So I'll just write out Codex and it will work. Like we saw, like we will try to have a tic-tac-toe. Okay, so let's see what, like, do you have our skills? I already asked it, like my Codex. You can do the same thing with your Claude as well. So this session has Vara Skills, which is including a set of specific gear and Vara skills, such as sale feature workflow, sale rust implementer, sales front end, sale gtest, sale ideal client, and Vara wallet and everything. And also you can actually test it out on your local dev node as well as on testnet on mainnet. We can see that as well. I already created few videos, you can check it out. Then I have 22 gear and Vara skills because it's keep changing, it's keep shipping, a lot of things are happening. So the Vara skills, a top level router for standard Vara sales framework. Then we have ship sales app, end-to-end workflow for specific test, local smoke. Then you have idea to specifications, implementation. Then you have front-end part, ideal client, G-test, local smoke. As we talked about, like there is a bunch of things you can just ask your codex what we have for in the menu. So what you can do, you can just go to this, and how you will install this and get it to your app is through this way. You can add it to your codex. Then let's see what we can have. Okay, let me just have a prompt. What we want to build it, guys. So pretty great. Once you have two ways, as I talked about Cloud Code and codex. You can just go and check it out if you have your codex set up or not. Okay, we have a prompt. How we got the prompt from here must just be replaced the rock paper scissors to tic-tac-toe. So let's just do this. Build an on-chain tic-tac-toe game on Vara using sales. 2 players commit hashed moves, then reveal, contract verify, select settles winner, updates and leaderboard. Also React frontend with wallet connect, game lobby, commit, reveal flow, retest coverage, that is for testing and also running a local dev node. Then adding voucher gasless mode, so you don't need to pay gas, you don't need to care about anything else. So it's a lot of things. If you build it, it would take like approx a day or so, but now your agent can actually do this in just one click, and it's already started working. We will just keep checking what it is doing and how it is looking like, and it will just keep shipping things. And so what we have till now is it checked it out what we have installed or not, and if not, it will actually do this for you, so that you are like a very newbie and you don't know how to actually build anything. As we talked about, like the skills point to a standard cargo sales scaffold, and to planning notes under docs/plans, and what these docs/plans are. Once it shows this in here in the repo, we will just check it out. Then it has certain steps which is we cannot see, but the scaffold the standard sales work phase with writing architecture and planning artifacts. Then we have implement the on-chain tic-tac-toe contract with commit and reveal, settlement, leaderboard and events. Can you think it, like if you coming up, you will just say, okay, build me an app. It will not be this much specific, and once you learn all these things to build it will take more time, but now it is very easy just with Vara skills. Then add G-test coverage on local smoke path, including voucher based gasless and validation nodes and scripts. Means you have your own testing way, and also you're running your own dev node. Then build the React front end with wallet connect, lobby, gameplay flow and voucher backed sends. Then you're gonna just test it out, the verification and any there is any gaps and all updates, which is like it did some work and some docs and plans. Let's see what it did. Okay, architecture note, build one standard sales program with one exported gameplay service program on state, stores lobbies, matches, leaderboard entries. The front end uses the generated ideal client all program interactions, and drop to your JS API only for the voucher issuance and wrapping. It's actually pretty specific. If you see what it did, it actually built out the architecture node. The second would be a feature spec, the problem standard on-chain turnout games expose moves before they settle, which enables copycat and removes hidden information gameplay. The app also needs low friction entry path for users who don't hold Vara for gas fees like that. That's why we're using vouchers and all other things. We have a task plan actually. So we have goals, means ship a greenfield Vara sales tic-tac-toe app with simultaneously commit reveal rounds, leaderboard tracking with changes in real time, then a React front end, G-test local smoke, and voucher based gasless support as well. preconditions. We have ordered tasks, we have dependencies, we have verification steps, we have review and checkpoints, we have rollback and notes. Okay, pretty great so far. Let's go. We just need to keep it like giving it more permissions, like it doesn't know that I always wanted to say yes, but yeah, okay. It gives me architecture way how it will, like it gonna generate all these things together. We will see, like at least we will see the deployed and also the contracts. So what these IDL, the client, means. So let's just talk about little bit about that. So just write client generation. You will go here, like it shows that the Sales.js CLI is a command line tool designed to generate TypeScript client libraries for sales IDL files. It automates the creation of fully functional clients libraries based on the interference based on the defined in the sales framework. So it's actually pretty cool. It means you can just go and install from here, and then what's the next step is, once you deploy those contracts, you can just give out the path for the ideal file to generate a TypeScript client. Means once you generate the ideal file by like cargo build release, what that means, I don't understand. Let me give you like a brief intro about that. So we did this in the last video as well. So once we go to quick start, we at the end, when we have all the things like contracts running, we want to compile it, right? We want to turn it to Wasm. Then we just run simply like like cargo build release. Then like this one, we just run it, and then what it does, it generates, like you have your contracts here, and then it generates a target folder, and in that you have your ideal file, and this ideal file helps you generate the TypeScript client. So you don't need to write your TypeScript client from scratch. You can do this with this simple line, which is this one that you generate, or like you already have. You just need to like give the path to your ideal file, which is your ideal file that is generated when you just ran this command, which is this one, like cargo build / release. That's it. And the best thing with Vara Skills is you don't need to actually do that manually. You can do that, get that with Vara Skills. It will automatically generate your client side as well. Okay, it's installing a bunch of packages here. Nice. Okay, so what it did, it basically installed the Rust and all the Wasm like dependencies and a bunch of things that it needed. Then it scaffolded the whole like the contracts. Then it actually tried to build it first, and then the best thing is it's actually thinking about the real scenarios. So it's checking it that the core contract shape compiled is far enough to expose real issues. Then a missing default derive on player stats and borrow check conflicts when finalizing a match. When finalizing a match means the match is like ending or something, and updating global state means the leaderboards and the points and everything else. And I'm targeting those finalization paths now to settle. Can mutate the match records first, and then update the active match map and leaderboard after the borrow ends. So it actually like going to map src to this folder, and it changed some things. Like it built the contracts initially, then it checked like what is working, what is not, and then it configured things with like what there is a host, there is a guest, there is a round number, there is a board, there is maybe an outcome, and so it checked and then it iterated on its mistakes. So it's pretty great that it's thinking in real time. Then what it did, we checked it out this one. So now we had contracts, right? We have these contracts here. We have here the tests. From here you can see, let me just show you. We have all these tests, we have the contracts here, and then it compiled the contracts. How it compiled the contracts, as we talked about previously as well. From here, like quick start, it did all these things. It write down the contracts, it checked if it's working or not perfectly. Then it compiled the contracts to this, and it generated dot wasm dot op dot wasm then dot ideal file like this one. But this one is for this specific project, but our project is different, which is tic-tac-toe. So our project dot ideal dot op dot wasm file and dot wasm file are different. So you can see the files here which is generated. I haven't touched a single line of code till now, but we will see what the outcome is at the end. It is now working on the client side, what we're gonna do there. Okay, we'll just keep checking on how it is doing all these things. Okay, now we have, it's pretty great that we have the contracts and like the next lobby ID, the next match ID, and it's pretty great that the agent is doing all these things, and it's pretty specific to Vara and sales framework. It's not easy to just write down, okay, build this. It will make mistakes, a lot of mistakes, and it's very time consuming, but not now. Okay, let's see what changes it is making till now. Okay, we see it added the new contracts and updating the tests, and also we will see the env files, we will see the initial testing phase, how it gonna look like, and it just start, guys. It just start. So let's see, we'll just excited about the outcome. Okay, just testing out the contracts. Let's just test out the contracts. Host ID. Okay, there's a lobby, there's ID, there's the host one, and then we have matches played, wins, losses for the struct and player starts, which is pretty great till now. And we see like, okay, nice. It's pretty detailed. It's not like a short contract, it's like an 881 lines of code. Great. And let's see, I mean, it just like few minutes, like not few, but yeah, actually 24 minutes, but it's still pretty fast. I mean, it's just thinking about the edge cases, the ways to make it more robust and also optimize it a lot more. Just click on yes. Let's see, I mean, who's not excited for the result at this point? Okay, we have these target folders. What we can do, as we do in the previous videos, if you are pretty interested how we deploy these contracts, you can go to like idea.tech.io. Okay, you can just go here. You can just connect your wallet, then yeah, okay, we have a polymarket here as well. So what you can do, you can have a bunch of ways, which is like Vara mainnet, Vara testnet. Currently we will be using DevNode, as we talked about during our deck, which is like we will be shipping on like DevNode. Then we will be moving towards testnet and mainnet depending on our preferences. So you have ways. You can just go to deploy in Vara testnet. You will be changing the RPC in your .env, which will be this one, and you can get your testnet faucets and you can continue your deployments. So the thing is, even though you don't understand a bunch of things that is happening here, you can reach out to us in Telegram and we will just help you out. Batch lifecycle, which is it is active or it is finished. I think it should be like ongoing or something, but yeah, we will see. If there's any issues, we can just change the contracts, or maybe ask it to add few features or remove few features, which is for later on, not now. Okay, I just approve one command and then we see front end. So we see front end, we see the env example file as well. Okay, we see on network RPC endpoint, we will see the program ID. Once it deployed the program, you will see the program ID, how the program ID looks like. You can maybe just go here and you can see the program ID. This is how the program ID looks like. Okay, maybe how you will just paste it, just simple go to this is a different program ID, by the way, but it will look similar to this, right? So okay, we have a very basic structure, not a basic one, but a bunch of things, means it is also working on the front end side. We have components, about action panel, copy address, debugging panel, event log, headers, manual call tab, network selector, state panel, wallet model, and it's doing all of these things by itself. Means we just did build the contracts, it compiled it, it ran bunch of tests, then it built out the front end, and then it will again run some test, and it will keep checking that is our app is working fine or not. So yeah, we now have front end, but we build out the front end and our contracts, and but we need something to connect it, which is like our client. So it will be building out a client as well, and it will be pretty straightforward, as we talked about how we can do this with this simple one line of code, directing towards our .idl file, and then it will just generate the client automatically depending on our contracts, whatever we compiled with cargo build dash release. Okay, pretty great till now. We see that this sales client.ts in front end, we can just check it out. Okay, so it thinks, it remembers, it negotiates itself, and then it performs action accordingly. So there is wallet.ts as well. Okay, it remembers like 137 the prefix. For example, what this means, we are creating a very long video, but let me just show you ssfta.org. right, if we go here and we just click or paste our wallet address here. Let me just copy a wallet address first of all. Okay, what we had, we have a random address which is from Substrate ecosystem. So we just had this address, and we can a custom prefix which will be 137, which is for Vara, and then we just click on convert. We can see the public key, custom prefix, Polkadot, Kusama, Substrate, and Vara. So you can see it actually picking up almost every point automatically. So yeah, with this 137 you can see this in our code as well, here, which is pretty great to see. Yeah, okay, I'm not using this one, you can just close it. So okay, let's see, I'm editing the front end now. The contract surface is stable enough that I can normalize sales query responses locally rather than generating another client layer. Okay, great. So as I talked about, there was automated client layer, and then it is just iterating and working on that to make it more robust and useful for us. We have chain providers, event providers, sales client. Okay, let's see, we have some updates. It deleted a bunch of things, but what it didn't delete it is usefulness. So we will just check it out. Okay, what it did, it actually just removed a bunch of things that we just not gonna use, or just are that just are no use. So it's changing bunch of things, and also redefining or redesigning the front end, and also working towards to make it live, because it's almost live now. Okay, the front end build is green, means everything is working well, because it run npm run build, and I think there was no issues. Okay, so I'm documenting how to run the local smoke path next, and then I'll do a final verification pass on the Rust test, so the repo closes with contract plus the UI status clearly separated. So what local smoke path will do, it will run a local dev node, and then it will just check it out, and you will see the program ID that will deploy on our dev node for now. So build the sales tic-tac-toe end-to-end flow, the contract, and this one already covers the lobby creation, joining, hashed, commit reveal verification, round settlement, and leaderboard upgrades, gtest suite. Okay, Then there is invalid cell loss. I replaced the scaffold demo front end with new game specific React UI in front end slash src app.tsx. Then bunch of CSS changes. Then you can see, I mean, for verification we can do this. And I did not complete a true local smoke run against a live local Vara node. The repo now includes the smoke steps in read.md, but I did not have a running local node and deployed program in the sessions. Okay, so let's ask it like, okay, perfect. But I run it. So we just wanted to use it to the full extent, because we can run it. We can easily run it. So I'm checking what can be run locally for the workspace right now. Local node availability, program artifacts, readiness, and whether the front end can be served against it if the tool chain is complete or something. Okay, the front end can run fully, but there is no Vara node. Okay. I think we need to run it from our own side, but it can do it for us. It will make some changes here with the endpoint because it will be for the testnet, but we are using at our devnet. So what I can not fully run, no. Environment, no gear, deploy CLI, not upload the program and execute relaunch in gameplay for the session yet. Okay, let's do it. It will just do the next step, that is set up the local chain / deploy path so we can run the actual local smoke end to end. So using sales local smoke with sales dev env because the blocker is environment. Okay, let's see, let's just test it out to the extent. After that, what we can do, we can run it from our own side if it doesn't goes to that extent. It is doing it, so let it do it for now. Okay, lot of things happened. So we just last talked about where we were deploying a local node to test out our program. After that, it did a bunch of things. I can see really front end immediately, but it doesn't have the tools. But I instead it to let's do it and let's find it out. So it actually did it, checked it out, then went to like Vara wallet. We have like Alice and Bob to test it out here. Then it checked it out. For example, let me just show you. Missing box is sandboxing. The local node is running outside the sandbox and the client commands needs the same permission to reach this point. I am returning the chain calls with escalation instead of changing the tools again. Okay, great. So then it ran Vara wallet. First of all, it ran this, which is for Alice, and it generated address for Alice. Let me just show you guys. I guess it got removed, but it basically through Vara dash wallet that it already has like this part of the skill. It generated a wallet for Alice, and then you can see the program ID here, the code ID is here, then there is salt, and there is transaction hash as well. All of these things are going on local dev node. Okay, what we see now is ideal confirm the constructor is create. I'm uploading the wasm file, then I'll immediately call. So what this uploading these op.wasm optimized wasm now, where it uploaded to like through here because it already has the was uploaded because of like generating the wallet address and everything itself. Then we can see the program ID here so that it can work around. And then what we have right now, this is the wallet address that it generated automatically through I've got a reliable commitment encoder now. Okay, great. Let's just continue. But The deploy is real and the live queries are good. Version returned 1 and open lobby is returned. Then I'm extending the smoke from program exists to a real match progress on chain. Okay, including a voucher back transaction. Great. So what we have now, so we have a Vara wallet, we are connected to a local dev node. Then okay, if you see, for example, if we go to here, you cannot see it now because we haven't deployed it here till now, but you can see the Alex is calling this one the create lobby. Then we have this tic-tac-toe IDL file from here that we already generated, not me but my agent codex basically. So we will just click on go. We are pretty close to test it out. Here as well, Alice calling this one, and you see the transaction hash, block hash, message ID, the block number. And let's just continue this for like this time. It's just trying with a voucher. As you can see here, Dan Vara wallet account is Alice voucher, issue for this address, duration is this much, risk program. If you're getting like messed up with these like terminal commands, just stay tuned. Okay, now we are doing this with Bob, means now you see this Alice because Alice has its own addresses, Bob has its own addresses, because we like showing you guys to interact with the two players, because you will not play a game solo when it is multiplayer. So you see this, right? There is a Vara wallet, there is a endpoint, then there is account of Bob calls this one. They're calling the same addresses, right? Because you see this address for Alice and then you see this address for Bob. Okay, because it needs to be same, otherwise they will be interacting in a different games. Okay, this is the hash. So we talked about, right, it needs to be hashed, the game steps and all. So you see these hashes and all these things are committing one by one. You see this for Bob calls the same address, and then the next move, it is game commit move. There is some arguments, there is a voucher for this address, and then like click on yes. Okay, you see these like block number are increasing. It was like 151 previously, it was around let me just show you, it was 108. Means it is working. The Bob and Alice, the things that we are doing, it's actually happening. So let's just see it. Okay, so basically it just shows me that do you want to continue a live local match by revealing Bob's voucher backed move. So yeah, why not? Let's just go. Okay, we ran these things, we ran on this address, then it is resulting as okay, there's ID, there's host, there is guest. So whatever things that we see in the contracts, means let me just go to the contract again. Okay, in the guest, for example, in the contracts we see there is guest, there is host, there is ID, there is like lobby and everything. So it is working on like executing everything by itself. Yep, you can see so basically what you see, it's running as our agent says. The live local pieces, the get dev node, you can see here there's front end preview here, there is deployed program ID for you guys. I'll just give it out in the GitHub, you can check it out from there. I verified the live path, not just builds. That we are keep saying, right? The Bob call, the Alice call to different like the addresses, but the same program ID. Um, because it needs to be the same program ID. Otherwise they will be interacting in a different program ID. So current live matches starts. There is match ID 1. There is board x empty empty empty. There is like 0. That's how the tic-tac-toe works, right? And there is next round. So the contract, deployed path, commit, voucher, gasless path, all exercise against a real local node. This is just one step remained. It will be a very long video, but let's see if we can do this. Okay, let's do it. Okay, if we waited till now, we can do this more. Hey everyone, if you remember, so far we created bunch of things, from contracts to front end to tests to deployments, and then we last time interacted to deployment related to our local dev node, but we tested in a terminal and it was working fine. So I did some checks, some errors, and then we deployed it to like the front end, the wiring and all these things. We funded with our some of our contract addresses as well as our wallet addresses. Then we are running a local dev node. We have our beat program ID. So everything we're gonna see in the front end is 100% working with a local network local node. So on the left you will see account number 1, on the right you will see account number 2. We created the lobby from account number 1 just for testing. Let me just connect my account 2. Yes, atomic settlement and on-chain leaderboard. This is not a normal one because players commit has to move first, means no one each other cannot see their moves at all, and then it will reveal later. If you want, you can reveal it right now, or you can just surrender, I don't want to play. Then let the contract resolve conclusions, invalid cells, wins, draws, or any surrenders. Voucher mode can sponsor your gas fee, so you don't need to worry about paying gas fees at all. Let's just issue the voucher from here. Okay, voucher issued for gasless transactions. We see the we already opened few games. So this user played 3 games, won 2 and lost 1. This user goes same. Okay, I hope we are okay. We are connected to the same wallet, but okay, this time the user around played 3. But so on the left you have wallet account number 1, on right you have account number 2. So you see like they have different games they played and won. So let's just click on create lobby. Okay, lobby created again, and you can see on the account number 2 the lobby shows, right? So let's just click on join on this lobby. Okay, voucher has expired, couldn't be used. We need to issue a new voucher, which is a good sign that it showing us the sign that you need to do these things with clear errors. Okay, it shows that voucher issued. We will just click on join. We will just join in this game. Join lobby. Okay, game started. If you see from the map endpoint, this is match 5, board match 5, board match 5. This is actually in real time. So let me just go and minimize my screen. I hope you can see all these things, right? Now what you see on the left, which is my account number 1 connected, on the right it is my account number 2 connected. When I click on any of the boxes, I don't see any no the other person will be able to see it whether I selected any move or not. So it shows that I selected 0 cell, 1 cell, 2 cell, how it shows like this, right? And the storage level missing. I can commit a move now. I can just surrender. I can show like, because I am a host, I created the lobby. I can see the guest is committed or not. The host revealed, I revealed my play or not. The guest revealed it play or not, which is the account number 2, which is my guest. So I'll just click on this middle one, and I just click on approve, and now it's like host committed. So this is how we will know that the host actually played its part. So now we can go and I can like click on this. It shows that host committed on both the sides actually, which is pretty great. So we will know that yes, host already played its chance. So now this time guest committed, and it shows that guest committed, right? And now what we want to do, we want to reveal our moves. So we can just click on reveal our moves. We will just go and reveal a move. So this time it shows that guest revealed its moves, right? And now what if the host also wants to reveal its move? Currently it shows that guest reveal its move, right? And we will just go and just click on approve. Now this time host reveal its move. So It may be sounding a little bit messy, but if we click on just settle round, it means just we want to settle this round. We can actually see these things, and we can just click on when both party agrees, then they able to see each other's move. And then, for example, the account number, our guest want to say, okay, I don't want to play, I don't want to play now, let's just stop this game. So it clearly shows that, right? It played like 4 games, win 1, 3 losses. And for this one it will be a win. So this one it will be like okay, I guess this is the wrong account I connected, but yeah, for this one it will be showing like played 4, won 3, 1 loss. So this is for different accounts. This time it's not mismatching with anyone. It is submitting a hashed move first, not like it is committing this one, and showing the exact outcome. It's a hashed outcomes, and it's committing on chain, and we built it using AI agents in under like few minutes. That's it. And the front end, the everything that you saw, the whole code, the whole repo, I'll just make it public, so you can just check it out. And it's pretty great, and it's pretty like good looking as well. If you go and see, and there's a bunch of things can be added. See you in the next video. Till then, bye bye, and just keep playing.